So this is where we ended on Friday, talking about increasing, decreasing, concave up, concave down. I introduced you to the fun chart so we could compare our functions to our rates of change. We're going to use the fun chart a lot. I'll kind of re-explain it as we go through today. But you also picked up a little half sheet of paper that has the fun chart, so let's look at that one real quick. It's just like what we wrote down, but just in case your handwriting looks like insanity, then you have something you can actually read. The first row, remember, refers to the function. We can see if our function is concave up or concave down or increasing or decreasing. The capital R stands for rate of change, so go ahead and write that in. I chose not to actually put the words rate of change in there because when you write the fun chart, I don't want it to feel cumbersome. I want you to be able to slap it down real quick. So we're just going to use a capital R for rate of change. And then some of the things that we want to know about rate of change, is it increasing, decreasing, positive, or negative? Analyzing the rate of change is what was kind of confusing for some people, but if you can tie it to the function, we can use our fun chart. But you also have to keep straight in your mind, am I talking about the function or am I talking about the rate of change? And you've got to be able to separate those things for that to really make sense. And I'll explain again what I mean by that once we start working some more examples. So here's where we were. Let's just kind of finish this part up here. It says, before we move ahead, it's important that we clarify a few things about notation and vocabulary. So one of the things is notation is very important. Vocabulary is very important. When you write your answers, writing them, it's not about how many words you have in it, is just, did you say the right things? Your sentences don't even necessarily have to be complete sentences. They should be close to that. And, they may not always be grammatically correct, like your English teachers might not like them, but it needs to say, we need to say what we need to say. So make sure you're paying attention to those things as I go through this and tell you what you have to write and why. So it says, first, when describing on a graph, we generally write intervals where the graph displays the features that we're talking about. And we always use the input variable when writing intervals. So one of the things I said on Friday a few times was, we look at y, we talk about y, but we write about x. And that's another thing that you got to make sure that you keep straight in your brain. Okay, we good on that? All right. All right, so if you grab your notes for today, they're also going on page 22. I will explain how that will work once we are to that point. And we're going to work through a bunch of examples here. So we have a function here, and it says the figure shows the graph of the piecewise function f over the interval from 0 to 9. So this interval that they give us here, does that include 0 and 9? Yes, it does, because we have the little underlines, right? All right, so what are all the intervals where the graph of f is increasing? So talking about f itself, not the rate of change, right? So graph of f is increasing, and as I go from left to right, I'm looking at my y values. F is increasing here, then it decreases, then it increases, right? So what I've highlighted in pink there, that's where it's increasing. So my y values increase from -2 to 4, but I really don't care about those numbers, right? Because we talk about y, we look at y, but we write about x. So it starts here at 0, increasing, and then it increases until x is 3. So I go from 0 to 3. That's the first time that it is increasing. You okay with that? We look at y, we talk about y, we write about x. And then I need to decide if I'm including these or not. So let me ask you, when x equals 3, do you think this function is increasing or decreasing? At 3. Increasing? Anybody think decreasing? Anybody think neither? Yeah? Anybody not really know? Okay, so here's the thing. Whether or not we include it, and So there are two schools of thought on this, and this is one thing that mathematicians do not agree on, and some people will get into very heated arguments about. I don't really necessarily need to get in a heated argument. I'll tell you what my thoughts are on that, and then I'm going to tell you what we are going to do. But I want you to know that there's two ways to think about this, because you might see it a different way, or you might end up with a professor in college that is adamant about doing it a different way than what I'm showing you. And I don't want you to think they're wrong or I taught you wrong or anything else. When we're talking about increasing or decreasing, if I decide I think I should include the 3, then I also have to include the 3 when it's decreasing, which means it's kind of both, but I don't agree with that. I feel like it's kind of neither, because how would you really know, right? So my actual opinion, like if I was going to jump on one side of the argument, is that we're not going to include it. And we are not going to include it more for well, that's because what I truly believe, but at the same time, more for consistency purposes. Because there's other intervals that we write for concavity where you cannot include them. And if you do, you're wrong. And I don't want you to get confused on when we include it and when we don't. You with me on that? So I think to me it's better just to be consistent. The only times we would include them is maybe if we were talking about domain. Like this domain here, but in interval notation, it would look like this, and I would include it because it's included, right? Or if I'm talking about positive and negative, and it's on a closed interval or something, but that's kind of rare. So really, for consistency, we're just not going to include it, which means these are open, okay? That's what it's increasing. And then it's increasing again, so that I can say and, then I look at my x values, 7 to 9. Like so. Those look like ordered pairs. Are they ordered pairs? No, they are not. Context means everything, right? So you got to know the difference there. What questions do you have? Anything? All right, good deal. Okie dokie. So second thing that needs to be clarified is the phrase rate of change. This phrase will be utilized repeatedly throughout this course, and in calculus we talk about rate of change a lot. So essentially, rate of change is simply slope, which I think you understand. We've talked about that a few times, and I think your teachers have done a good job of kind of forcing that in your brain. So anytime you see rate of change, you can just replace it with the word slope to kind of make sense of it. Don't think that it has to be complicated, like it's just slope. I've been in slope forever. I can make sense of this, right? Then it also says we must read very carefully in this course. Okay, you have to actually read and not skim and not assume things, right? So if I state that f is increasing, it's very different than stating the rate of change of f is increasing. F can be increasing and the rate of change of f could be decreasing. So this is what I was talking about, like when you get confused with increasing and decreasing. What are we talking about? Are we talking about the function itself? Or are we talking about the rate at which the function changes? And those are two completely different things, all right? A lot of words in this last part, and it's all kind of filled in for us, so we're going to circle and underline. And I know the answers to some of my questions are right in front of your face, but let's kind of pretend like they're not. So when I look at this first graph here, this is the graph of f, right? So f, meaning the graph of f, not the rate of change. As the x's go from left to right, I have x's that are negative and positive. But as the x's go from left to right, all of the y values are positive. They're all above the x-axis. That's what makes the function itself positive. You with me on that? The function itself, as x goes from left to right, the function values, the y values are getting smaller and smaller and smaller. That's why the function is decreasing. If we are talking about the function, we don't need the fun chart. As soon as we see the rate of change of f, that's when we want the fun chart. Okay? So we're going to write out our fun chart. And I want you to actually write it out, because the more you write it out, the less you have to think about it when you write it. And I want you to get in the habit of writing it. Okay, so rate of change. I want to know if it's increasing or decreasing. If I want to know if the rate of change is increasing or decreasing, I look at the function, and the function I want to know, is it concave up or down? So is this function right here concave up or down? Up. It is concave up, therefore the rate of change is increasing. And that's what it says right there. Do you understand how to use that chart? What we know about the function, what we know about the rate of change. So then with that said, looking at that fun chart, do you think the rate of change is positive or negative? Negative? Anybody think positive? If I want to know if the rate is positive or negative, I look to see if the function is increasing or decreasing. Function is decreasing, so the rate of change is negative. Make sense? Another way to look at that without the chart is we could draw those little lines we talked about on Friday like this, or use your pencil. So when I look at this, I know that's a negative slope. I also know that it's negative going towards 0, and then if it went back up, it'd be positive. So that's also what tells me that my rate of change is increasing. It's another way to look at it. Okay. What questions do you have? Okay, so let's look at G. As x goes from left to right, all of my y values are below the x-axis. That's what makes the function negative, the function itself. And as x goes from left to right, the y values are getting bigger and bigger and bigger. That's what makes the function increasing. Everybody okay with that? Then when we get to rate of change, we want to look at the fun chart. I mean, I have it right there, so I don't necessarily need to rewrite it. If I flip the page, I do. So is this concave up or down? Down. Concave down means the rate of change is decreasing. Is the rate of change of G positive or negative? Positive, because the function is increasing, right? You see how all that works together? What questions do you have? Ask me a question. Don't be afraid. Okay. Okay, so now here's what happens. You're like, this is great. I get it. I totally get it. Then we start to work some examples. Then you start questioning things, and then you start getting yourself confused. And if that happens, you need to start asking questions then, okay? Because sometimes we're like, oh, yeah, I totally get it. Then you get to a question like, oh, thought I got it, right? Which I'm sure you do. Overall, this concept isn't difficult. It's just some people, it's kind of easy to get things mixed up if you don't understand how to separate it yet. All right, so let's flip this over. So if I haven't mentioned this already, last year was the first, or if you didn't already know, last year was the first year AP Pre-Cal existed ever. So it was a year of a lot of unknowns as we went through things. And College Board gave us information, and we tried to decipher that. And we had some practice problems, but not a lot. And so we learned a lot last year. We know a whole lot more, still not as much as I'd like to know. But one thing that is very clear is that AP Pre-Cal, the FRQs, are very different than most any other AP test because they are very, very specific about telling us what they're going to look like. So in other words, we know a whole lot. Like, I know in a lot, you might know that FRQ 1 and 2, this is what could be on there, but like, it's kind of really narrowed down. And there's a lot of things that I don't know about what FRQ 3 will look like, but I can't guarantee you it will look exactly like this example, okay? But a couple of things that are different, you will have to put in the numbers. We're not ready to do that. We didn't even look at questions like this until the second semester. And then because we had to put numbers on it, it was really mind-bending for some people. So hopefully us starting this sooner will not make it so mind-bending for y'all. Let's see. Because the numbers are already there, because this function and stuff, we don't even talk about that till second semester. But the stuff, the increasing, decreasing, all that stuff, we're talking about it now, so we can go ahead and look at it now. So let's read this. The graph of h of t, and it's dashed midline. Okay, so what a midline actually is, we talk about officially next semester. But look at it. It's in the middle. It's not that hard to figure out what it's talking about. For 2 full cycles is shown. 5 points, F, G, J, K, and P are labeled on the graph. No scale is indicated, and no axes are presented. So this is where the problem came in when we had to put numbers on, which we're not going to have to do right now because you wouldn't know. It wouldn't make any sense to you. But the no axes, like I could draw my X and Y axis on there if I wanted to, and I would know where to put it at this point. But here's the thing we got to make sure we understand. These are ordered pairs and not intervals, right? Because again, context. So, and this is not a trick question. In an ordered pair, is the first number X or Y? X, okay. So that means that all of my X values, as I go from left to right, have to go from least to greatest because that's how the X-axis works, right? And then my Y values have to go from least to greatest as we go from the bottom to the top because that's how a Y-axis works, right? So make sure that you keep that in mind every time we look at one of these, because when we start to actually have to put numbers on it, that's when things went wild, man. We had numbers all over the place, and I was like, did y'all forget how axes worked? I don't know what's happening here, so just keep that in mind. All right, but that's not really what this question is about. So it says the t-coordinate for F is T1, so I'm going to put a T1 here, and the t-coordinate for G is T2, so I'm going to put a T2 here. So then it says on the interval from T1 to T2, and it's telling me it's an interval, so it's this part of the graph, which of the following is true about H? We're only being asked about the function. So do I need to look at the fun chart right now? No, I don't need it. It's not going to help me any. So I need to figure out, is it positive or negative, and is it increasing or decreasing? So let's just start with the positive negative part. From T1 to T2, do we think the function itself is positive or negative? I heard negative and I heard positive. Okay, let me ask you this. When we're looking at the function and to decide whether or not it's negative or positive, what do we look at? The Y values, the function values. So these are my Y values from T1 to T2. So is the function positive or negative? Positive. Okay, so I'm going to mark out the ones that say negative. Then is the function increasing or decreasing there? Decreasing, because once again we look at the Y values, and the Y values are going from 4 to 0. As I go here, it's decreasing, so H is positive and decreasing there. Okay, we good on that? Ask me a question. Okay. Okay. All right, so then it says describe how the rate of change of H is changing. So as soon as I see rate of change, I want to write down my fun chart. Okay, so here we go. And if I want to know how it's changing by either increasing or decreasing. So I want to know if it's increasing or decreasing, which means for the function, I look to see is it concave up or down. So on that interval from T1 to T2, is the function concave up or down? Down. Okay, so if the function is concave down, the rate of change is decreasing. 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 It is negative, because the rate of change is negative because the function's decreasing, but that's not what they're asking me right now, okay? So they're asking me this. So this is what we have to write. We have to write the rate of change of H is decreasing. So far, the only thing I can really abbreviate is decreasing, but at least it's something, right? The rate of change of H is decreasing on T1 to T2. And then I can abbreviate because. B/C works for because. So the rate of change of H is decreasing on T1 to T2 because H is concave down on T1 to T2. Do not ever say it, because it is doing this. What the heck is it? All right? Sometimes you might feel like you're kind of repeating yourself, but this is the way it works, right? My opinion doesn't matter. Your opinion doesn't matter. We want to get credit, yes? So there's two parts to this. So I'm saying what the rate of change, who of h is what decreasing where on this interval. And then who, h, is what concave down on where this interval. Okay? So I got to have all of that. Got to say h twice and whatnot. Now, I could have said it flipped around. Like I could have said h is concave down on T1 to T2, therefore the rate of change, blah, blah, blah. That's totally fine. And your words don't always have to match mine exactly, but you have to make sure that you have all the important pieces in there. Okay? We good on that? What questions you got? All right. Don't get sloppy with your words because you lose credit big time. Let's look at example 4. The graph of h of t and its dashed midline for 2 full cycles is shown. That is exactly the same words as the last one. The next sentence is exactly the same, and the next sentence is exact. The first 3 sentences exactly the same as the last one. This is the sentence that changes. So read that. You can talk about it amongst yourselves. Just do the first one here. Let's see what we can figure out is going on here. Actually talk to each other. That would be nice. Okay. Let's look at this real quick. So the function itself, I want to know if the function is positive or negative. What do you think about that? Negative, good, because we look at the y values, right? It is negative, so I can eliminate those. Is the function increasing or decreasing? Increasing, negative and increasing. Okay, everybody okay with that? I heard some arguments about a number line over there. Did we get it figured out? No. Are we mad at each other now because we're fighting about a number line? Okay, just making sure. Sometimes I got to go break up fights, and they're about math usually, but okay. Yes? Why is it increasing? Because the values are going from -4 to -1. So I heard you mention number line. So let's talk about a number line. Here's 0, here's -1, here's -4. I'm going from -4 to -1, therefore my values are increasing. Is that what you were trying to, that's what you were trying to get across? Okay, good job. Okay, so then let's look at this one. It says describe how the rate of change. So now without looking anywhere else that you have it, I want you to write out your fun chart. Try and write it out without actually looking at anything. Just so, and then you can always check yourself, make sure you're right, but this should be pretty easy to write out. Because if you write it out wrong, it's not going to help you any, right? Okay. So I want to know if the rate of change is increasing or decreasing. So I look at the concavity. Is this concave up or down? Down. So the rate of change is decreasing. Okay. So I'm going to write this backwards from the last one just to show you could do it either way. If you already have it written the other way, that's totally fine. But I can say here, I can say that H is concave down on T1 to T2, right? And then I can do, what do those little 3 dots mean? Therefore, H is concave down on T1 to T2, therefore, the rate of change of h is decreasing on t1 to t2. So basically, I just wrote it kind of in a reverse way. Either way is fine. Honestly, I don't even think I'm consistent when I do it. It's like if I write down a thought and then I'm like, oh, got to have the other piece. Do I say because or therefore? And it's fine either way. What questions do you have? Anything? All right. Why is it concave down? Okay, well, it's concave down for a couple of reasons, but if it's concave up, it's like it's concave up from here to here, concave up like a cup, and then this like down like a frown. Does that make sense to you? You got that? Okay. Okay. Okay, the numbers you see, that's not going to change the concave up or concave down. Based on the shape and also based on the rate of change. Like what we're kind of doing is looking at the shape and saying, oh, the rate of change is decreasing or whatever. But I can look at here and say, like if I have these like this, I can say it's negative, then it's 0, and it's positive. So since the rate of change is increasing, that makes it concave up. That's another way to look at it. Does that help? Okay. Because this, okay, that's a good question. All right, good question. So the question was, why is it increasing here and decreasing here? Because here we are talking about the function, and here we are talking about the rate of change. Those are two different, and that's the part where I say you got to separate it, right? Which one am I talking about? I know, because I know it gets confusing. But am I talking about the function, or am I talking about the rate of change? Does that help? Okay, you're welcome. Anything else? Okay, thank you for asking.